Hi, everybody. Welcome to our first day of section 3.2, Investigating Quadratics, on page 13 of your booklet. Today what we're going to do is we're going to do a little review of what we did the other day, and we're going to change these into standard form. And this kind of is an introduction to where we're going to go in the final section 3.3, where we're going to be able to go from into vertex form, from standard form into vertex form. So we're going to do a little investigation what standard form looks like, and then we're going to go on from there. So it is, as you can see, our question is in vertex form, but we will put it into standard form when we're finished. But when we have it in vertex form, it helps us with a lot of pieces of information. So let's move on. Let's go. So we have our graph here. You can see, and there's our equation. So what we're going to do is we're going to take our equation and we're going to list, first what we're going to do is we're going to list the transformations. So the transformations, what do they look like? And I'm going to do it short now because you guys know, you've seen them before. So it's a reflection reflection about the x-axis, right? And instead of me saying vertical stretch of 2, I'm going to say VS of 2. So then remember, the reflection is because of the negative in front of our equation. The vertical stretch is the 2, which is the coefficient, or A value, if you do recall. And we also have a vertical translation of +9. So that vertical translation equals 9, or of 9. You can say equals or of. It's okay either way. I'm fine with. And then a HT, which is a horizontal translation of, or which is equal to, remember it's -3, so we put 3 in here because it's minus our p-value. All right, so the mapping notation, which helps us give a table of values. So mapping notation and a table of values, we'll do it together. So I'm going to go steal that from the other day. All right, so we're going to add in our mapping notation. Before we did the -3 and 9, I'm not going to do that this time. You can if you wish. It's completely up to yourself. But I'm just going to use 5 points. 5 points is usually enough for the quadratic. Use the vertex and then 2 other points on left and right side of the parabola. That'll give you more than enough to be able to get the shape. So we're going to put in our values. Remember, the p-value is going to be our horizontal translation. So it was -3 in the equation, which means it's +3 in your mapping notation. It's negative, so I have the negative up front. The A value is 2, so it goes in directly as 2. Our Y value, obviously we're going to plug that in from these points right here. And then our Q value is just our vertical translation. It was +9. Okay, so we're going to plug this in. -2 + 3 will give us 1 for your X value. So I'm just putting -2 in here. -2 + 3 is 1. Your Y value, put in 4 in. -2 multiplied by 4 is -8. -8 + 9 is 1. So this means that point, -2 and 4 mapped onto 1 and 1, which is this point right here you see in your graph. Right? It's making sense. You can see that clearly from your graph, but sometimes it's not so clear, so that's why I'm using a table of values. If you can get the table of values from your graph, or you plug the equation in the TI-84 calculator, it's up to you how you want to get your table of values. I'm just showing the longer way, just so you do remember it. Okay? And I'm going to copy that. And the next one would be, obviously, it's going up by, you can see it's going up by 1 each time, right? So I'm going to put all the X values in. So it's 3, because 0 + 3 is 3, 1 + 3 is 4, and 2 + 3 is 5. Then I'll fill the Y values in. I can fill this Y value in at the same time. This here is also going to be 1. Why is it going to be 1? Because both the points have -2, 4, 2 and 4, they both have a Y value of 4, so that's going to yield the same Y value when you put it in your mapping notation. Put 1 in there, that would give us 7, because -2 times 1 is -2 + 9 is going to be 7, so this will also be 7. And then your vertex is 0, 0 on your original. Remember, this is your original function. We don't have that on the graph. You don't need that. 0 multiplied by -2 would be 0, would be 9. So 3 and 9 is your vertex, which you see right up here in your graph that you do have on your page. Okay? So there's your mapping notation. All right. And table of values. So your mapping notation is this part here, and your table of values, I do them underneath. I kind of do them hand in hand. It's up to you how you want to approach that. The direction of the opening, it opens downward, obviously. The coordinates of the vertex. Coordinates of the vertex are going to be, you can just go v 3, 9. Oh, I said faces there, 3 and 9. So that's right here. The vertex was 0, 0 mapped onto 3 and 9, and you can clearly see that in your graph that it is 3 and 9. That point there. Is it a minimum or maximum value? The maximum value, they're looking for the y value is equal to 9. So the maximum or minimum value, it's on aspect coordinate, is asking for that. That's your 9 right here, so that's where the 9 comes in. Axis of symmetry, that's your x equals. Oh, x equals 3. X and y intercepts, if possible, they're not perfect. You'll notice it's a little less than 1, it's a little more than 5. So we'll get the graphing calculator to determine these, or Desmos, either way, determine those values. So I'll get the graphing calculator, clear y equals, we can clear this, we put our function in, it's -2 bracket x minus 3, close bracket squared, plus 9. Graph that, there's your graph, and remember to get the x and y intercepts, we go second function calc, calculate 0, 0, 0 x intercept for your graph, so we go up, which is to the right, hit enter when we're just to the left of it, hit enter again, and we see we get 0.088. Take at least 2 decimal places, or 2 or 3 decimal places after. If we have 1, don't just put decimal 9, put decimal 88. Okay, we'll do the same thing for the second 0. And again, you guys should know how to do this. We did them already in the previous class. So it's second function calc, left bound, right bound, enter again, and we get 5.12. All right. So the x-intercepts are, and we derive as points 0.88, 0, and so that's the x-intercept. X-int for short, x-intercepts. That and 5.12 and 0, and y int is 0 and -9. Now we don't have that in our table of values, but if you went back 1 and you put it in, if you had 0 in here, so it would be -3 and 9, that would actually give you that point. But again, you can clearly see that it's there. If not, you can substitute x into your original equation. It would be x is equal to 0, and then you would just calculate it. So it would be 0 minus 3 squared, which would be -3 squared, which would be 9. 9 times -2 is -18. -18 plus 9 is equal to 9. So however way you want to get that. Domain and range. The domain for this particular graph is going to be x as an element of the reals. X is an element of the real numbers. It's not a real, like it's not a word problem question like where it has to stop and start. So there's your domain, and your range is obviously, if you look at your graph, all you need to do is look at your y value of your, so your maximum value here, right? So we had a maximum, right? Underline maximum. So maximum, and we had a max value of y equals 9. So that's where your range comes into play. So it'll be y is obviously less than or equal to 9 because it's a maximum and it goes down, right? So it's all your y values from 9, including 9, all the way and going downward. That's it for that question. And now, oh, sorry, now we have to put it into standard form. Standard form is easy for going from vertex to standard. It's when the opposite way, which we're going to do in the next section, it becomes a little more difficult. All right, so we'll expand that, and we get that's -3 squared, right? So that means it's -3 or x minus 3 multiplied by x minus 3. That's the expansion. That's what it looks like. So gotta be careful there. So I could multiply that with x squared. You guys know how to do that, or you should at this point. We should be able to multiply two binomials, and I'm just going to write down what we get. So we get x squared minus 6x plus 9 brackets, right? So I expanded it and I multiplied the binomial by binomial. Now we're going to multiply by the coefficient of 2 in front. So it would be negative 2x squared. Negative times a negative will give you plus 12x, and negative 2 multiplied by plus 9 would give us minus 18. Those are the brackets, and then these are like terms, so we add those two together, and our final step, negative 18 plus the 9. And in standard form is y. Remember, standard form is sorry, I don't know what happened there. It's touchy. There we go. And we just add them together, we get negative 9. So the standard form is y equals, or f of x equals a x squared plus bx plus c. There's your standard form there. The final. Okay. So that's it. That's, again, good practice with our transformations, writing all of our information from our graph and putting it in standard form, because the next lesson, after this videos of 3.2, we're going to go into showing how to change that into vertex form. A little more complicated. It's called completing the square, but we'll get it done. All right, thanks. Hope you like the videos. Please give me some feedback in class, and I appreciate you watching. Thanks, everybody.